Welcome to another test and teardown video. Yes, I got the entire Siemens receiver system, but this video is only going to be this one. The Siemens long range or long wave. It's a converter. So this is actually, I think this is means front end or something in German. So what this does is actually a pre-selector or pre-converter for receivers that don't cover the really long waves or very low frequencies, obviously. So all those really low frequencies are selected by this band switch. I really like this mechanical construction. This is very user friendly. Can you imagine using this one? Select the right range, dial in the frequency, and Barbara's your uncle. This is really nice, right? So what this does is it takes this frequency and it converts it to 20 megahertz. So this is the output that goes to your receiver, a 20 megahertz receiver. And all those very low frequencies, they come in here in the high impedance or low impedance antenna inputs. So yeah, that's basically what it does. Very simple, but it's still a very heavy unit. I was reading on the internet about this, and I think they said one radio tube and the rest is transistors. So let's see if this is true. I am a little bit... Is this okay? This wire is kind of not so safe anymore. So I think we're gonna start the teardown and do the repair and then test it while it's still open, because I don't want to, blow any fuses or stuff like that. So that's what we're gonna do. So that was easy. The screws, they were so loose I could just take them out with my fingers, so that was fantastic. First, I wanted to repair the mains wire, but look at that, what I find. A mains connector at the rear. Ooh, let's move it in a little bit more like this. Now it can stand on its handles. So there's a good old style mains connector with chassis ground and everything. It is here already. But why wasn't that used? And they're using a wire out of the front. This is so annoying when you got those cables in the front. I've never liked it at all, but this was really the standard in the 50s and 60s. But why are they continuing with this annoying cable stuff? And let's look at the case. It's right here. So this is here it is. This is the rear side of the case. They already cut the hole. So all you have to do is remove this, and then you're ready to upgrade it with a mains connector. That is nice. Really a good quality case as well. So here's the mains cable rear side. In the old days, red was the chassis or ground. So that is quite typical for 50s, 60s. I don't know if I really like the way this is soldered to this. So how do you turn this around and get this out? Why didn't they use one of those screws here? This is not exactly how you would do it today. Voltage selector is really nice. Just pull this and move it. See, the voltages are nicely written here. So that is super easy to configure for new voltage. And the fuse is on the front. Yeah, so that is great. Yeah, this is definitely an all transistor unit, so I was definitely looking up something wrong. See, the switch here is, I've seen this type of switch before, but it has been modified or taken to pieces and then mounted with a PCB on each side like this. Isn't that just amazing design? So this is the frequency dial with the anti-backslash for even the readout, and obviously for the capacitor as well. This runs amazingly smooth. And where have we seen this type of end stop before? Down here? Rode Schwarz and HP, also using exactly the same kind of end stop system. So that is seen before. I think it's a little bit funny with the bulbs. They're mounted up there, and then the shine light down here. But since this is a okay, this is metal, and again, this was made in the 50s or 60s. Today you would put the bulb inside here, right? And then this should have been transparent or something. That could have been really, really nice. So, and there's a nice box here with all the 20 megahertz up converter things. And what is that? This is one of the outputs. And again, super shielded. That is really nice. Let's look. Move. So that will be, oi, look at that. So this will be the band. Yeah. This is the band switch. So there's a wire here on the band switch that goes, yeah, maybe it's not that easy to see, but there is a wire going under here, two of them, and that is what pulls the red slider or the red indicator. All this feels really, really good and stable. Those clicks are good and accurate. Well, because of this roller is really big, so this is a lot better quality than you normally see, right? See a roller. So this makes sure that you touches or you hit exactly the correct position. Gold plated PCB. Oh man, it is good with a shielding plate in the middle. What is that as well? Oh, that switch here. You need to pull it and change the settings. And look here at the back how it is done. Let me see if I can get some more light in here so we can see this. Yeah, that was not good. Can I show you guys this switch? That is also very, very special. And then we got some fuses. Why would we have some? Really? That would be fuses on the antenna. Inputs via fuses. Really? That is interesting. In here. So that is, of course, if there's a lightning or a DC connection to the I need to check if those are good or not. Also, we need to open this box and have a look, right? Let's open this together, shall we? That is really, really nice. Look at this shielding from the bottom. Oh, those are just really pro. So where's this one going? Okay, so this is the output. But why is there like a crystal here on the output? Is that in a socket? No, it's not. So this is probably a filter, crystal filter or something on that output. This looks a lot like, hey, yeah, look at that. It's a double balanced mixer, all this. See? Got one transformator and then the 4 diodes and the other transformator, and then match for the 20 megahertz output. So this is definitely a double balanced mixer. Ah, this will be the injection. So there's a crystal. So this oscillator here, and this is the injection. So that means this. Ah, so this is the input from some of the bands, and this one is input from some of the other bands. Why would they do it like that? Well, that's a little bit funny. Yeah, that is how it is, because we got 2 different outputs here. DC is filtered really nice and good. What exactly is that? That looks a little bit like a coil that is standing up, or some funny stuff. I don't know yet. Maybe I'll have to look a little bit deeper into that. So all this metal is mounted in this chassis, but even that, they still wanted to add an extra wire. But those goes in here as well, all those. Okay, yeah. One extra wire is definitely gonna make a big difference. Oh yeah, the power supply is also very neat. All the capacitors, even the small ones, mounted with 2 screws. Look how everything here is done. Metal and screws and wires. It almost looked like military or flight electronics. This quality level here, they really wanted this to look like a million. Okay, so this one fell off. Ah, so this is a tape you open, and then you can access the screw, and when you're done, you put on the tape so you don't get dust and stuff inside this trimmer capacitor. That's quite neat. And again, ground wire. I really like the quality level of this. Now I just need to see if it's working. So that is a nice new mains cable connected and all that. And what do you know? I found the tube. You wanna see it? Yeah, a Novistar. Of course it's there. Maybe we can. Doing. Come on, come to Papa. Here we go. Oh, let me put it. Ah, no. 217 yen? Really? 7587 RCA. That is a beautiful Novistar. in a socket. So yeah, there was a tube, because this kinda count as a tube, I would definitely say. A small one, but it does count. So that means if you touch this, it's gonna go ow ow in your fingers, okay? I believe we're ready to do the power on. No. 11, 10, 9 watts. Oh, both of the bulbs works. Isn't that just pretty? I love it. Wow, look at the readout. It is absolutely fantastic with the light and all that. All right, better go and get some cables. Let's see if it works. Of course it works. How can I think any different? See, here's how this thing actually works. So this is the antenna input. I just put in 1 megahertz. So this, in this setting, I just use the internal preamplifier, a wideband preamplifier, and then I get a factor of a lot more input. Look at that. Just, what is that, 10 millivolts? And look at that, 200 millivolts per division here, right? So anyway, this is the preamp version. Let me try and turn the output on and off. See? I'm not lying. It's coming from here. So this is 1 megahertz of very, very little signal. So then I go to the converter. And now I need to select this range. Okay? So here's 1 megahertz. So look what happens when I dial. Ooh, now I'm gone from. So you see what happens? Then I go to 1 megahertz. Ooh, I get a lot of signal. So this is a mixed signal with the 20 megahertz carrier and my 1 megahertz. It is converted now into a 20 megahertz. See, if I turn off my 1 megahertz, then I get this weak signal here. There's actually a 40 megahertz. This is of course a signal that is not supposed to be there. I think we should just adjust this system right here, and then this will probably be completely gone. And this is not intended. You see? So this is of course the oscillator that is leaking through this crystal filter. I bet if we take something here and even just touch. Ooh. Nah. That's just. Anyway, this cool thing really works. And what if I give it a lot more? So that was 10. See? Now we'll see our output. Then I can. Here we go. So that is my 1 megahertz converted. How about we change the different ranges? We could of course do that as well. So this is 22 to 50 kilohertz. Is that one? So 30 kilohertz, okay. And we see nothing. So let's go 30 kilohertz. Bada bing, bada boom. And here is our 30 kilohertz. And then I can of course fine tune. Ooh, here we go. Yeah, so this converter works. Fantastic. I'm really happy about it. Everything about it. I really love it. See about this Novista. Remember what I said about touching the top? Yep, that's exactly why you don't touch stuff.